Okay, I think we're going to get started here so we can keep this train on time. My name is Jim Friend. I'm your MC for the Intro to Crypto track. And for this session, we're going to be talking about decentralized finance. And we have back again Xavier, who was with us earlier this morning. But just in case you missed that talk, I'm just going to provide a little introduction to Xavier. He is a widely followed YouTube creator on technology. He's a native of Belgium. His channel, Simply Explained, has more than 430,000 followers and over 28 million views, making him one of the most recognized technology commentators in the world. Both his work and hobby are in technology, focused mostly on blockchain, machine learning, serverless applications, the Internet of Things, and more. His Simply Explained YouTube channel focuses on making the complex simple, putting technology topics in plain, simple terms that all can understand. Xavier received his bachelor's degree in computer science at the Hoge School Gent. He works full-time as a full-stack developer at a large bank in Belgium, which gives him a unique perspective as he lives daily in both traditional banking and the new world of internet finance. Please welcome Xavier.
Right? Okay, great. Thank you everyone for coming to this talk. Thank you for the nice introduction once again. I also prepared some introductory slides again as well. So hello, my name is Xavier. I am indeed the creator of the YouTube channel Simply Explained. And I have a passion for taking complicated topics and explaining them in a straightforward way. And that is what I do on my YouTube channel. I make animated explainer videos about all kinds of technology, about cryptocurrencies. I have videos about blockchains, DeFi, NFTs, but also about databases, caching, and I even have a video about SpaceX, how they design, launch, and land their rockets. So, what am I going to talk about today? I'm going to start by giving you a definition of DeFi. What is DeFi? Then we're going to take a look at the underlying technologies that make DeFi applications possible, mainly blockchain and smart contracts. Now, there were already some talks about blockchain, so I'm just going to give you a quick recap, and we're going to focus mainly on smart contracts. Then I'm going to give you lots and lots of examples of DeFi applications that exist today, so you can get a feel for this space and see what is possible. We're going to look at the advantages and the disadvantages of DeFi applications. And at the end of the talk, there will be time for questions and answers. So I foresee around 40 minutes of me talking about the first 4 items and around 10 to 15 minutes for your questions. Now, the goal of this presentation is to give you a broad overview of the DeFi space. We're not necessarily going to go very deep into detail, but rather just giving you an overview. So let's get started. Let's start with the basics. DeFi stands for Decentralized Finance, and it's basically an umbrella term for financial applications that are built on top of blockchains. That is the definition of DeFi. Now, I found another definition on the internet that is like way cooler, and it says that DeFi is a global financial system that is built for the internet age. Now, this is a bit more exciting. And so what DeFi wants to do is it wants to put us back into control of our finances. And now you might think, well, aren't we already in control of our finances? We get to decide what we do with our money, right? Well, kind of. Our current financial system is highly centralized. We are highly dependent on entities like banks, insurance companies, credit unions, and investment dealers. Without them, we can't get much done. And these companies don't always have our best interests in mind. For example, a bank can decide to lock up your money. They can decide that you cannot withdraw your savings, for instance. They can charge high fees, exchange one currency for the other, and the bank will say, well, thank you for your business, but we also need a cut of that. And banks can just outright block transactions. There's a lot of banks that don't allow you to transfer money to cryptocurrencies exchanges, for example. So, how can we decentralize this financial system? Well, turns out we've done a part of this already with cryptocurrencies. A cryptocurrency is a decentralized form of a currency. It allows us to send payments to people directly, peer-to-peer, without middlemen, no banks. And yet, it is still completely secure. There are no middlemen, and it is secure. So how does that work? Well, cryptocurrencies rely on blockchains. So let me give you a quick recap of what a blockchain is. A blockchain is essentially a decentralized network of people that are working towards a common goal. In the case of a cryptocurrency, their goal is to reach consensus. They agree about how everyone has spent their funds. They agree about all the transactions that have ever happened. And they do it in a way that even if hackers come along, they cannot game the system. The people keep the consensus alive as long as the majority of this network is honest. So, blockchains, completely distributed. They're open for everyone. Anyone with a computer and an internet connection, they can join this network. And it is completely immutable, which means that you can only add new stuff to a blockchain. You can never change stuff that has already been added. So this technology seems like a great foundation to build other financial applications on top of, right? Except that there is one small problem. Blockchains are static. And what I mean by that is that blockchains are great at recording transactions, and I can add a new transaction to it. But a blockchain cannot take actions on itself. It is entirely reliant on users. So let's imagine that you and a business partner or spouse, you want to open a shared account, a common account for both of you. On a blockchain, on a standard blockchain, that is not possible. So you might want to open this current account, you want to deposit money into that, and then maybe you want to configure this account so that you can only release funds when both partners are in agreement. This happens in business a lot. Well, to accomplish this, you need something called a smart contract. What is that? Well, a smart contract is basically a bit of computer code. It is a computer program that lives inside of a blockchain. And because it is living inside this blockchain, it inherits all the properties of the blockchain. It means that it is accessible for everyone. There are no middlemen. It is completely immutable. Once you've created your contract, you've determined the terms and conditions, you cannot change them anymore. And computer code is always fair. It's always consistent. Given a certain set of input parameters, it will always take the same action. It doesn't discriminate. Smart contracts can automatically perform certain actions on a blockchain. Well, what kind of actions can it do? Well, for starters, a smart contract can send and receive coins. I said that contracts live on the blockchain, and that means they get an address. And you can send coins to that address, and then the smart contract can do stuff with your funds. It can store additional data. For example, in the case of the common account, maybe the smart contract keeps track of how much money each person deposited into the account. And maybe you also add some logic that if you close the account, it will automatically distribute the funds still in it based on how much each participant added in the first place. Contracts can also interact with other contracts. So in fact, you can string multiple simple contracts together to create a more complex financial application. And basically, a smart contract can do just anything that a user can do with a blockchain, except in a completely automated way. Now, let me give you an example of a smart contract. Crowdfunding. You might be familiar with a platform like Kickstarter or Indiegogo. It's basically a platform where you can go to if you need money to develop a product, for example. So you go to Kickstarter, you create your project, you say how much money you want to collect, and when enough people donate, your project gets funded, you get the money, and you can take your product to market. Now, in this system, there's really three parties involved. There's the supporters on one end, there's a product team on the other, and there's Kickstarter in the middle. And both parties have to trust Kickstarter to do the right thing. So a supporter trusts that if the project gets successfully funded, Kickstarter will give the money to the product team. They also trust that if there's something wrong with the project and it fails, that they get a refund. And the product team likewise trusts Kickstarter that if everything goes well, they will get their money. Well, there is a way to completely eliminate this middleman. You can replace Kickstarter with a smart contract. In this case, the supporters now send their money directly to the smart contract. The smart contract keeps those funds locked up, and it's programmed to release them whenever the project is funded. Project gets funded, the funds are automatically transferred to the product team. And if you want, you can program it to also refund the supporters in case that the project fails, if it fails to meet its goal, for example, in the first 90 days. So the logic of this smart contract would look something like this. And don't worry, I'm not going to put code on the screen, and just a high-level wireframe. So whenever money is received, the smart contract will check whether or not the goal has been reached, yes or no. And if the goal is reached, it will transfer the funds to the product team. And if the goal is not reached, it could refund the supporters. Now, this is obviously a simplification of the logic of such a smart contract. In reality, you might want to add a time component in here as well. Say that the project needs to be funded within a certain amount of time, and otherwise everyone gets their money back. Now, that's one application. Now let me give you some cooler examples of DeFi applications. I will give you 6 examples in total. Crowdfunding was one of them. So let's take a look at number 2. Decentralized exchanges. If you attended my talk this morning, then we briefly mentioned what a cryptocurrency exchange does. It's basically a platform where you can send euros and dollars into, and then you can use that to buy cryptocurrency assets. Well, in this case, once again, the exchange is a middleman. You can get rid of this middleman with a smart contract. Instead of relying on the central authority, you rely on a bit of computer code. You create your order and you send your coins to a decentralized exchange. I say, for example, I want to buy 1 Bitcoin for 100 Litecoin. And I send my 100 Litecoin to the smart contract. Then the smart contract will look at all the orders that it received and it will try to match people up. If someone else wants to do the exact opposite that what I want to do, then it will match us up and it will give us both the coins that we wanted. So what are the upsides of a decentralized exchange? Well, they often have lower fees. A decentralized exchange doesn't have an office, doesn't have employees, doesn't have expenses. There's no middleman. There are no humans involved. Everything is completely automated. And they often have support for way more coins and tokens. Now, these things are very good. Just last week, we saw a major cryptocurrency exchange go bankrupt, FTX in this case, because they mismanaged their users' funds. A decentralized exchange cannot do that because it's a bit of code. It's a computer program that always executes in the same way. Another example is decentralized lending. You know, if you want to borrow some money, you have to go through a bank. For example, you might want to buy a house. So you go to your bank and you say, hey, I want to borrow some cash for a house. And the first thing that the bank will say is, well, let us see if we want to give you a loan. So tell us who you are, where you work, what other assets you might have, and so forth. And then, if that all checks out, the bank will say, okay, we're going to give you a loan, but we'll also need some collateral. In the case of buying a house, that is your mortgage. If you don't repay your loan, the bank is entitled to take your house and sell it off. So what a bank is doing is it's sitting in between savers on one hand and borrowers on the other hand. It takes the savings and it gives them to borrowers in the forms of a loan. And then when that money is being repaid with interest, the bank takes a cut and also gives part of that interest back to the savers. Well, you can, once again, completely decentralize this. There's a platform out there called Aave that currently lends out $6.5 billion. And they do the exact same thing as a bank, except that they do it with a smart contract, with a bit of code. People deposit money into that smart contract so that they can earn interest, the savers on one end, except that here we're not talking about savers, we're talking about liquidity providers, but it's the exact same thing. And then the smart contract decides to lend that money out to other people. And in this case, the smart contract also requires you to put up collateral. But in this case, your collateral is in the form of cryptocurrency. Now, wait a minute. If you want to borrow cryptocurrency, you have to put cryptocurrency up for collateral. Why is that useful? Well, you might already have a lot of Bitcoin, for example. that you don't want to sell, but at the same time, you also want to buy maybe some Ether. Well, you can do that with a platform like this. You send your Bitcoin to the smart contract, it will lock it up as collateral, and it will give you some Ether in return. And then over time, you pay off your loan, and you will have both your Bitcoin and your Ether. Another example, real-time finance. If you're an employee, then you probably get paid like once a month, right? At the end of the month, you will get all of your money in one go. Well, what if you could get paid way more frequently? What if you could get paid for every day that you worked, or every hour, every minute, or every second? Well, this is what real-time finance wants to do. There's a protocol out there called Xavier, which is a protocol for real-time finance, and it's basically a smart contract where your employer or anyone else deposit a large amount of money into, and the contract is programmed to release those funds over time to you based on a set of conditions. For example, it might be programmed to pay you for every hour that you were at work and you were checked in. Another example, and this is quite a popular one, NFTs. An NFT stands for non-fungible token. Non-fungible means that two items are not the same, that they are unique. For example, one piece of art is not equal to another piece of art. You cannot trade or exchange these pieces of art. Fungible items, on the other hand, are different. Regular currencies are fungible. If I have $1 and you have $1 and you swap them around, nothing really happens. We both still have $1. We don't care about the actual dollar bill that we have. Nothing makes that unique. So what can you do with an NFT? Well, you can track ownership. You can track who owns a particular digital file or a physical asset, even if you want. It's mostly used for digital files, though, because digital files are a bit weird. If I create a document, I can replicate that document as many times as I want. And everyone that I sent this document to will have an identical copy of the document. So how do we now know who owns the original file? Everyone has an identical copy. We cannot know. Well, NFTs solve this problem. You create your digital file, you take your digital file, could be like a digital piece of art. You take the unique properties of that file and you encode that into a smart contract. You take the fingerprint of your file, you give it a name, you give it a token name, you put that all into the smart contract, and it's almost like you're creating your very own cryptocurrency with just one available coin. Once it's created, you can then take your token, your NFT, you can sell that to someone else. And now that person is the owner of your digital file, your piece of art, whatever it may be. And it's just a smart contract that lives on a blockchain, and blockchains do what blockchains do best. They keep track of transactions. They keep track of when your NFT was created. They keep track of every time that NFT was sold. For example, my piece of art was sold for 1 Ether by user X to user Y. And you can make NFTs out of pretty much anything. You can make them out of digital art. You can sell tweets as NFTs. There's the founder of Twitter who sold his very first tweet for a couple of $1 million, I believe. I think it's 20 million or something. You can sell concert tickets as NFTs because each concert ticket is in essence unique. A concert ticket is for a certain band at a certain date with a certain seat assigned, for example, and you cannot exchange one ticket for the other because then you're seated somewhere else. Or you could use it for rare in-game items, a skin in Fortnite or a specific item in Minecraft, for example. Basically, you can create an NFT out of anything that is unique and non-fungible and of which you want to track ownership. You want to track who owns the original. If you want to learn more about NFTs, I actually have a full video on that on my YouTube channel. It's What is an NFT? And it just takes 4 minutes, and I'll go through a lot more detail. Now, the last example I want to give about DeFi is a DAO. DAO stands for a Decentralized Autonomous Organization. And it's basically an organization that is governed through a blockchain. That means there's no boss and there are no managers. The structure of a DAO is very flat. All people are equal. And in this DAO, you have shareholders, and every shareholder has a vote. They can vote on what the organization should do next. And the proposal with the most votes wins out. You probably guessed it, this DAO is a smart contract that lives on a blockchain, and the smart contract keeps, first of all, track of all of the shareholders. You can create a bunch of shares of your DAO, then you can give them or sell them out to people, and these shares are then used to vote on proposals. So for example, one group of people might say, well, let's use the money in our DAO to buy Twitter, for example, because that seems like a great investment. Some other people, another group may say, well, let's take our money and invest it in a new cryptocurrency platform, for example, because that's also a great idea these days. And then people can use their shares to vote on the ideas they believe in, and the idea with the most votes get accepted and automatically executed by the smart contract. So, the smart contract of a DAO, first and foremost, stores all of the funds, all of the money of that DAO. It's all locked into the smart contract. It tracks all the shareholders of the organization, and it facilitates the voting process. It makes sure so that every shareholder can propose a new idea or an action. Everyone can vote, and once a proposal is accepted, the smart contract will carry out the decision. For example, we voted to buy Twitter, the decision is taken, the smart contract will automatically transfer the necessary funds to another account. And it encodes the other rules of engagement. You can encode pretty much anything in the smart contract. For example, you might say that all proposals within my organization need at least a 60% majority before it's being accepted. Or you could say, well, my organization always needs to have a certain amount of cash in reserve. And because it is a computer program, the rules that you encode into this smart contract are strictly enforced. If you say a 60% majority is needed, then that's always needed. There are no exceptions to this. So how can you use a DAO? Well, a charity could use a DAO, for example. You take all the donations that you receive, you put it into that smart contract, and then you let people vote on how you should use those funds, which projects to back or which equipment to buy. You could use it for collective ownership. You come together with a group of people, you pool together your money, and then you decide, for example, to buy a house and rent it out on Airbnb. Venture funds could also be digitized in this way. You come together with a group of investors, you pool your capital together into a DAO, and then all of the investors vote on which startups you're going to support. So these are just 3 examples, but you can use these decentralized organizations in many different ways. So these are just 6 examples of DeFi applications that exist today. They're already being used. Now, I want to make a quick side note before I continue with the presentation. We think that DeFi is this hot new topic that only came about like a couple of years ago. But I was reading through the Ethereum white paper, and I found out that Vitalik Buterin, the creator of Ethereum, actually mentions practically all of these examples in his original white paper. That was back in 2013. So I think, between you and me, that he's a time traveler, that he came from the future, and he brought that knowledge back to 2013 and he wrote this white paper. I mean, that got to be the only explanation, right? Okay, but anyway, I digress. Back to the main presentation. Let's take a look at the up and the downsides of decentralized finance. Let's start with the upsides. I mentioned a lot already. DeFi applications are decentralized, open for everyone, built on top of a blockchain. Everyone is equal. There are no requirements to join this network. Everyone is equal. And there's no censorship. There's no one who can tell you what you can or cannot do. Another upside is that you're fully in control. There are no middlemen. It's only you who decides what you can do with your funds. And there are no restrictions. There's no bank that can tell you that you can't transfer money to such and such person or organization. DeFi applications also have the potential for speed and efficiency. There is no legacy infrastructure. Banks often have very old systems that aren't really fast. Not the case for DeFi. There are no manual steps in operations. There's no people involved. Everything is computer code. Everything executes on the fly. And you can do high-speed transactions. I gave you the example of real-time finance, where you could potentially stream money to another person every second. Try sending a transaction to many people at once through the traditional finance system. But with all upsides come downsides. And some of the upsides that I mentioned are also downsides. For example, you're fully in control. That is a good thing. But users aren't always clever. For instance, if you want to do things properly and you keep your cryptocurrencies in a wallet with a private key attached to that, then you're responsible to keep your private key safe. And if you forget the password or you forget where you stored the file, well, then your funds are lost forever. They're still there on the blockchain, right? But there's no way for you to spend them anymore. In fact, we read this in the newspapers every now and then of people who are having millions of dollars of Bitcoin, but they can't remember their passwords. Or they stored their private key on a thumb drive somewhere, and they threw it in the trash, and now they're looking at it in a landfill to try and recover it. Another downside is scalability and speed. I mentioned that there is the potential for speed and efficiency, but that potential is not always there. I'm going to give you a simple example. The top two cryptocurrencies today, Bitcoin and Ethereum, they can handle 7 and 20 transactions per second, respectively. These are not the systems where you want to build a new financial system on top of. They're just way too slow. Now, luckily, there are solutions for that. Some projects go to hundreds of transactions per second or even thousands of transactions per second. And Ethereum is aiming for hundreds of thousands with Ethereum 2.0, which hopefully should come out next year. Another downside is user experience. I mentioned this in my cryptocurrency presentation as well. Right now, these DeFi applications have a lot of potential, but they're just not that easy to use. There's a lot of jargon. You need special software, browser extensions. There's a lot of phishing attempts. It's just not that easy. Another downside, security. I said that blockchains are very secure, and that is true. I didn't lie. However, the smart contracts that are built on top of this blockchain are different. They're bits of computer code written by people. And whenever people are involved, we have the potential for mistakes, for bugs to creep into this code base. In fact, here are some examples in recent history of smart contracts that contained a bit of flawed logic, and hackers were able to take advantage of that. They were able to trick a smart contract into releasing funds to an address that it really shouldn't. And there's quite a big one here. There's one worth $570 million that was stolen from Binance. And what doesn't help is that these smart contracts are immutable by default. That means that once you've created your smart contract, you've encoded all your rules and your conditions, and you discover a security issue, you cannot go around and fix it. It is set in stone. Now, luckily, there are some ways in which you can upgrade smart contracts. There are ways in which you can create a new one and transfer the funds of the old one into the new one. But if you don't think about it when you create the first version of your DeFi app, you're done. You find a security issue, there's nothing you can do. Another downside, and I promise that I will stop soon with the downsides, is safety. There is no regulator. This stuff is completely decentralized. And that also means there are no guarantees. I found a study that was conducted, I think 2 weeks ago, or it was published 2 weeks ago, that claimed that 97% of tokens on Uniswap were actually rug pulls. It was people coming up with cool new ideas, cool new technology, DeFi applications, promising a lot of things, but ultimately they were just out for everyone's money. As soon as enough people had invested into their project, they disappeared with all the money. So these were some of the up and the downsides of decentralized finance. Now let's address two common questions that I get when I talk about DeFi. And that is, on which blockchains do these applications run? And how big is this DeFi space? Let's look at the first one. On which blockchain do DeFi applications run? Well, they run on a variety of blockchains and platforms, but the biggest one right now is Ethereum. And Ethereum has sort of a first mover advantage because they were the very first to introduce this capability, these smart contracts, onto their blockchain. Now, other projects are catching up with Ethereum, and they're usually catching up because they are faster and they have lower fees. So Ethereum might be able to keep spot number one if it innovates and it brings out improvements to their speed and efficiency and to their fees. And the second question is, how big is DeFi? Some people are scared that they missed the train, that they are too late to invest in this stuff. Well, let's take a look at how big it is. Last week, there was an estimated $58 billion worth of money locked up into the DeFi ecosystem. That's a lot of money. Now, if I zoom back out, that actually used to be way more. At the end of last year, that was over $244 billion. Again, it sounds like a lot of money, but let's compare it to the global wealth. If we compare it to that, then DeFi is just 0.05% of all of the wealth in the world. So I would say that it is still early days for DeFi and cryptocurrency to an extent as well. There are many, many hurdles to be overcome. I talked about some of these in my talk. For example, they're not so scalable at the moment, and they're not so easy to use. So I think that cryptocurrencies and DeFi in general have a very bright future, but these things need to be resolved first. So let's summarize. I started by talking about DeFi, and I gave you a broad definition of what DeFi is. We talked about the underlying technologies that power DeFi, mainly the blockchain and the smart contracts that make it more dynamic. I gave you lots and lots of examples of DeFi applications. We talked about the advantages and the disadvantages of DeFi. And finally, we addressed on what blockchain they run and how big this DeFi space is. So that leaves me with promoting my socials. If you want to learn more about cryptocurrencies and other technologies in general, definitely check out my YouTube channel. It's called Simply Explained. You can also follow me on Twitter, and if you want your curiosity tickled every month, then you can sign up for my newsletter where I highlight all kinds of cool features, all kinds of cool things that I found on the internet related to science and technology. And with that, I want to thank you for coming, for paying attention, and I propose that we use the remainder of our time for questions. Thank you. Yes?
How does proof of stake versus proof of claim impact? Does it apply to this, the shift in those things?
Xavier, so when someone asks a question, if you could just restate the question so that when the recording plays back, we can...
Right. So the question is, how does proof of work and proof of stake relate to this?
Yes.
Yeah. Well, proof of work and proof of stake are examples of two consensus algorithms. So they make sure that all the people are on the same page, that they agree about all the transactions that have happened. The main impact that they have is how fast they are. So some consensus algorithms trade off security for speed, and therefore they can handle thousands of transactions per second. But if you talk about proof of work and proof of stake, then those two are generally considered very secure and about equal in terms of performance. Yeah. So it doesn't impact that a lot. Yes?
Yeah, what do you think of you mentioned user experience is a big issue. What would you say are the biggest user experience issues that you see?
Okay, so what is the biggest user experience issue I see in DeFi? I would say managing your cryptocurrencies, right? So you need cryptocurrency to be able to spend it on these platforms, to be able to lend money, for example, or to be able to stream it to someone else in real-time finance. And managing your own cryptocurrency wallet is difficult. So you need special software. They spit out a public key and a private key. Those are two files on your computer. How do you secure them? How do you store your private key in a safe manner? Do you print it out on paper? But then you risk losing that piece of paper, or if your house burns down, you lose it as well. There's things like hardware wallets that can solve some of these problems, but then you need to buy a physical device. That needs additional software. It doesn't support all the cryptocurrencies to begin with. So I would say that managing your wallet and your private key, I think that is the most fundamental thing, and it's still something that is not so user-friendly. Yeah. Thank you. Yeah.
So you talked about people getting these smart contracts, stealing money through the smart contract.
Right.
But if they're just doing something that the contract allows, is it really a crime? Like, how do you...
Okay, right. So, yeah, the question is it a crime if you trick a smart contract into releasing funds? Are you then actually stealing? Well, the thing is that you're basically exploiting loopholes in the logic of the contract. So it's not necessarily that the contract will allow you to steal funds from it. It's that the contract doesn't check all of the conditions. It's not careful enough. And so if you send it the right amount of input parameters, you could trick it into releasing the funds. So it's an unintended consequence of the logic and the code not being thought through. It's the same thing with security issues on your phone, for example. If you see that your iOS or Android, they put out a security patch, for instance, that's not because they, well, I hope not, that they intentionally put a backdoor in the system. It's that it's an unintended consequence. They forgot to check a certain condition, and an attacker is able to take advantage of that and break into your phone, for example. It's the same thing for the smart contracts.
So then you're relying on regulators again, which is the police, to police your smart contract to go after the people who do this unintended thing. So you're not really a decentralized organization anymore.
Right. You're not necessarily relying on the police to monitor these smart contracts. You're instead relying on the community. So a lot of smart contracts that deal with a lot of money, they are open source. And what that means is that there's a lot of people looking at the code and finding potential issues before they can be exploited. So a lot of contracts are open source, and they have a mechanism in which they allow upgrades to be made. So if you find a security flaw in your contract right now, you can create a brand new one and transfer the funds into that brand new one so that the security issue is fixed. So I wouldn't say that we need law enforcement necessarily to look at these smart contracts, but I do think that being open and transparent and open source, having a lot of people looking at your code, that definitely helps to weed out the bugs and the unintended consequences. Yes?
In your Kickstarter example, you used a smart contract as replacing them as the middleman. But who funds, builds, secures, maintains the smart contract? Isn't it really just a modern software application?
Right, okay. Question is, who builds the smart contracts? A lot of smart contracts are indeed built by communities, by groups of people that are coming together on GitHub, for example, and they have this idea about building a decentralized Kickstarter. They come together, start writing code. When it's finished, they submit that to a blockchain. Now, there's an interesting thing about fees. I said that smart contracts or these decentralized applications usually charge less fees. I didn't say that they charge no fees. They charge less. So often these contracts are programmed to take a little bit of money and to store that in a treasury that the product team can then use to either pay themselves so that they can further develop the smart contract or later distribute it to the people who participate in the application, who are actually using it. Does that answer your question?
Sort of, yeah.
Yeah. Okay. Yes?
So if DeFi runs on protocols that are coded to be trusted and coded to handle everything and manage everything by itself without human error, that means that there's no central, power or force or company to create the protocol, to enhance user experience, for example, which is why we see Coinbase kind of take over the market, even though it's centralized and kind of isn't exactly in line with the whole point of DeFi.
Right.
So what incentives, I guess my question, what incentives are there for people that want to go into the business world in DeFi to, build on the space, to make it better, to make it more user accessible?
Right, okay.
Doesn't seem there's many incentives.
Okay, so the question is, what incentivizes people to actually build these these DeFi applications? The simple answer is that you write the logic of the smart contract so you can decide what you charge for it. For example, the lending platform Aave, they do the same as banks. Whenever a loan is repaid, they take a cut before they give the interest back to the liquidity providers, for example. So that is the incentive. You basically make a DeFi application and you make sure that you collect enough fees so you can fund yourself, basically, and fund future versions of it. Yeah.
So I guess then just to follow up,
Yep.
who's they in Aave if it's a protocol?
Right.
Who is, you know?
Right. So most of these are, again, open source projects. So it's the same thing like if we're talking about Linux, for example. Who is Linux? Well, it's not a company, really. It's just a bunch of volunteers on the internet, a bunch of geeks that are passionate about this technology who want to build applications for it. That's the they that I refer to. It's really just people on the internet. But to be fair, I think you could build a company around that as well. You could perfectly say, I'm going to be a decentralized lender, and I'm going to make sure that I collect enough fees to pay my employees and to pay my offices and stuff like that. There's nothing really holding you back from doing that. Yes?
As someone who's trying to break into like industry such as like programming and stuff like that, what would you recommend them to do to kind of build their profile up to kind of land one of the smart contract engineering jobs, or even like a hybrid smart contract with chain? Like, how would you recommend someone trying to get into that? What should they do?
So okay, the question is, what would I recommend that people do when they want to get into this space? Well, once again, I have to say, open source is a big draw. A lot of these things are open source, so I would say make a GitHub profile, make some smart contracts, and just try out a lot of things. And it doesn't necessarily have to cost money. So for example, Ethereum, they have a test network that is very cheap to, it's actually free, I think, to run on. Make smart contracts, make mistakes, write code, learn the language first and foremost, so that's Solidity in the case of Ethereum. And for that, there's a lot of resources online. I know that there's a game, I think it's something with zombies. It's not crypto zombies, but it's something like that, that it basically gives you it gives you a challenge that you need to write a smart contract for to solve the problem. And the challenges get harder and harder as you progress. So that is a great learning environment, for example. So I would say start with that, learn the language, write a lot of code, deploy it to the testnet of Ethereum, and then ultimately publish the contracts that you've created for everyone to view on GitHub, for example. Yeah. Yes?
Two questions. One, talking about how the longevity of smart contracts, what happens if the blockchain underneath needs to fork or it maybe starts to die down? Is there a way to take smart contracts and move them to, say, another blockchain to keep going? And then with the smart contract itself, like when you do upgrades to it, like you're talking about, does it have to do upgrades that stay in sync with the blockchain, or can there be an upgrade that would potentially not make a smart contract work anymore? How does that work out?
Okay, so the first question is, how does, wait, can you repeat the question again?
The first one, I'll do the first one first. Is just if something happens to the blockchain, like it forks or people have to use it, are the smart contracts still operational, potentially be able to?
Right, so what happens if a blockchain forks? Okay, so if a blockchain forks, it's essentially the same as taking a photocopy of the blockchain, and that blockchain then continues on independently. So if you have a smart contract that was deployed to Ethereum, for example, and someone forks Ethereum and calls it Ethereum 2.0, for example, then your smart contract now lives in both places, and it keeps operating in both places. Except for, from that point on, your smart contract and the activity that it sees will diverge. So some people will run certain actions against the smart contract on Ethereum, and other people will run other actions against the other chain. So your smart contract keeps working. And then what happens if a blockchain dies out? Well, then your smart contract dies out with it. If there's really no participants left anymore in your blockchain, there's no one in this network anymore, then all the data is gone. The blockchain is eventually just lost. The data is erased. And your second question?
If there's an upgrade to the blockchain itself, like, for example, Ethereum just moved from proof of work
Right.
to proof of stake. Is there any upgrades that must take place in the smart contracts for them to operate?
No. So the question is what happens when a blockchain upgrades, for example, and the proof of stake migration of Ethereum. In that case, there was no change to the EVM, the Ethereum virtual machine, which is the code that runs the smart contracts. So in this case, it was a completely backwards compatible upgrade. And I believe, given how much money is locked up into Ethereum contracts, they can just not afford to make breaking changes. They do upgrade the programming language though, so Solidity does receive frequent updates. And so if you make your smart contract, you have to say which version of Solidity that you used, and it will always use that version to run your smart contract, even though there might be like 10 new versions released later on. Yeah. So everything is backwards compatible. Okay. Yes?
How sophisticated are the smart contracts? Like, for instance, can you design a self-adapting contract like with genetic algorithms or reinforcement learning or something like that? I don't mean like patching it so it can't be hacked or can't be exploited. I just mean, can you use some learning techniques to adapt the parameters of it as people interact with it in the world?
Yes. So the question is, can you make a smart contract change its own parameters on its own? The answer is yes. So Solidity, the programming language, is a fully complete language. And the variables, this is a bit weird. If you're programming a traditional computer program, the variables that you use in that program, they disappear as soon as your program stops running. In the case of a smart contract, the variables that you create are actually stored permanently inside the blockchain. They're stored amongst all of the people that are participating in this network. So if somewhere in your code it says, as soon as I received X amount of transactions, for example, my fee will go up, and you change that parameter, everyone in this network will run that code, come to the same conclusion, and they will change that variable and up the fees, for example, or downscale them or whatever. Yeah. So that's perfectly possible. Yeah. Machine learning contracts that automatically patch themselves, that would be even cooler, but I don't think that was attempted yet. Yeah. Perhaps maybe in the future, so who knows. Other questions in the back? Yes?
To what degree have you seen like real world or practical world uses of DeFi lending? Like traditionally when I ran into it is kind of the example you provided of like putting up collateral because I have Bitcoin but I want some Ethereum as well. But what about a world of like putting up collateral asking for a lower fee loan for a house or just a personal loan? Like is that as popular you just didn't really talk about it or where is it?
Yeah, so can you use these decentralized lending platforms, for example, to not only borrow cryptocurrencies, but also real-world assets? The answer is that doesn't really happen. The space is still very young when it comes to decentralized lending. And in fact, it's so immature that the amount of collateral you have to put up to get a loan, let's say that you want to borrow $1,000 worth of Ethereum, for example, the collateral you would have to put up for that is going to be maybe twice or 3 times that amount. And the reason for that is that cryptocurrency values are very volatile. And so a platform like Aave needs to make sure that if the price of your collateral drops spectacularly, that they can still cover your initial loan. And so I think for that reason, it's still limited to borrowing cryptocurrencies. I'm sure there are some people who have done it for like a house, but it's an exception rather than something that happens commonly. Yeah, but it's definitely possible. Technically, that's surely possible. Yeah. Yes.
How do you think like Oracle, such as like Chainlink, are going to apply this in the smart contract world? From my understanding, like Chainlink just a giant database that can access all the data in the world and put it on the blockchain. So like I feel like that's going to be a major player as it becomes more mainstream. So what are your thoughts on this hybrid smart contract?
Okay. So you're mentioning oracles, which is like a very difficult topic to explain because if you want to take real-world data and you want to put that in a blockchain, you have to make sure that is also distributed, that multiple people can validate what has happened in the real world and that bit of information is captured correctly into a blockchain. For example, you might want to store temperature of a specific city in the blockchain. How do you do that? Because everyone should be allowed to contribute that. One solution is that you allow people to or you incentivize people to submit this data to the blockchain, and you look at the variance between the data. So some people will say, oh, it's 15 degrees, some people will say it's 16 or whatever. And you basically take an average and you punish those who are outliers. So people who say that, oh, it's 80 degrees in my city, while in reality it's just like 15. So that's one way in which you can do it. But this is a very important, an important topic that isn't fully solved. For example, the real-time finance example that I gave, that you could get paid per second that you worked. If you say that you will get paid only if you badged in to work, for example, you need a way to get the badging data into the blockchain. And that needs to be distributed. And that's a hard problem to solve. So these oracles is not really well figured out. And it's also not good if you let your employer do that, because then it's a central point and they have all the incentives to lie about it. Yeah.
Well, we're all out of time. I'm so sorry to cut this short, but let's give a
We
big
can
round of applause
continue.
for Xavier. This was wonderful.
Thank you.